Okay, so we're going to do a guarantee problem with the normal distribution, and hopefully you've had a minute to read over your problem, and hopefully you've tried it out before coming here. But if you're here, then it means you're confused, or you just really want to know, did you get the right answer? So what I did in this problem was I let x bar be the mean life of the watch in months, and it told me in the paragraph that x was normally distributed with a mean of 25 and a standard deviation of 5. And it was really important to note that basically what they're saying is if the watch dies before X months, then they have to replace it. That's their whole guarantee situation, okay? If the watch dies before some value X, then they have to replace it. And they don't want to have to replace more than 10% of the watches, okay? So what they're saying mathematically is this probability that X lasts less than some number needs to be equal to 10%, or what they're saying in a picture view is they're saying, hey, here's the amount of watches that are gonna die, and we don't want this area to be anything more than 10%, right? So what you gotta do is figure out what is this number right here. Well, it's some z value. It's a z-score, and it's negative because it's on the left-hand side of 0. And then what you have to do, since you know it's a negative z and you know you're looking for 10%, you've got to go inside your table here and you've got to search in the table and try to find 10%. You won't find it exactly because you never do, but you got to try to get as close as you can. So I'm going to come down here at about negative 1.2, and if you look in here, we're getting really close to 10%. There's 1038, there's 1020, there's 1003, and there's 0985. That's too far off. That's too far off. This one's the closest, 0.1003, and its corresponding z-score, well, you go out to the negative 1.2 and up to the 8, so put it together to be a negative 1.28. That is the z-score according to the table. Once you've done that, you're ready to go to your formula. So pretty much drawing the picture, getting it set up, that's step 1. Finding that z-score was step 2. You're ready for the last step at this point because you've got to find an x value. How you get an x from a z is with the formula x equals z times sigma plus mu. Okay, so that's just a formula. Once you get the formula written down, plug in everything you now know. You now know z because you looked it up. You know sigma is 5 even, and you know the mean mu is 25. So multiply and then add. You should be getting about 18.6, and this was in the unit of months. So they need to make their guarantee for 18.6 months if they don't want to replace more than 10% of those watches. And that's all you got to do on guarantee problems. Number 4 is also a guarantee problem, and number 5 is also a guarantee problem, but it's technically a cutoff score problem, but you work it the same way. 4 and 5 are both, I got confused. 4 is a guarantee problem, and 5 is not a guarantee problem. It's a cutoff score. But they're both inverse normals. That's what they're called. So this is an inverse normal distribution, and this is an inverse normal, and they're commonly applied to guarantee problems, and they can also be applied to cutoff scores. So handle it the same way, and you should be fine.